Good morning to all. This is Uma Shankar working as a lecturer in EC at Government Polytechnic College, Kosi. So today I am going to deal with the subject Advanced Engineering Mathematics for electrical engineering students in 4th semester. So today my topic is the Fourier series. In this I am going to discuss about the Fourier half-range series. Okay. So in the previous class we have seen that the definition of the Fourier series expansion, and also we have seen the Euler's formula, and also we have seen the continuity and discontinuity of the Fourier function, and also we have seen the odd and even functions. So the even function which contains the Fourier cosine terms, and the odd function which contains the Fourier sine terms. Okay, so in this class we are going to discuss about the half range Fourier series, okay, and its expansions, and also we will see the half range Fourier cosine series and also the sine series. Okay, so in the previous classes we have seen that the Fourier function which is represented over an interval of, okay, for any Fourier series for a given function which is represented over the interval of minus pi to pi or 0 to 2 pi, or it can be c to c plus 2 pi. What is the length of the interval of these three? That is nothing but the length of the interval can be a 2 pi only. Okay, but in most of the engineering problems, okay, the period of the function to be expanded is not always a 2 pi. Sometimes it may be also represented by some other quantity which is nothing but your L, where L is the interval. Okay, where L is the length of the interval. Okay, now we'll see that how we are going to represent the half range Fourier series. Okay, half range Fourier series expansions which can be used in this class. That is nothing but any half range Fourier series expansion for a given function which can be defined in the interval of, okay, c to c comma c plus 2l. Okay, c comma c plus 2l of length. What is the length of the interval? 2l. So instead of 2 pi we are taking the length of the interval is 2l, which is a new quantity. Instead of 2 pi we are representing the 2l. Okay, we will have the c plus c comma c plus 2 pi. Okay, instead of 2 pi we are taking the new quantity c plus 2l. Okay, right. Okay, right. So in various physical and engineering problems, it is required to obtain a Fourier expansion of a function defined in the half of the interval. Okay, it can be defined only for half of the interval. Say it can be represented as 0 to L instead of minus L to L or 0 to 2L. Okay, it can be defined for only half interval, that is represented as 0 to L. Okay, it can be represented as 0 to, where L length is your L, where length of the interval is your L. Okay, such expansions are known as the half range expansions or half range Fourier series. So this type of expansions are called as a half range expansions or half range Fourier series. Okay, right. So now, so sometimes it is required to expand the function f of x, okay, in the range of 0 to pi in a Fourier series of period 2 pi, or in the range of 0 to L. Okay, in place of pi we have to use L here in a Fourier series of a period of 2L. Okay, in a Fourier series of a period of the 2L, instead of 2 pi we can use as a 2L here. And sometimes it is immaterial or irrelevant, whatever the function may be outside the range. It is 0 less than x less than L. We extend the function to cover the entire range, that is nothing but minus L to L, so that the new function may be represented as even and odd. Either it can be even or odd. The Fourier expansion of such function consists of cosine or sine terms only. Okay, right. So if it is represented, the new function may be even and odd. If it is an even, the function is even, it consisting of only cosine terms. If the function is odd, it can be represented as sine terms. Okay, it can be represented in terms of the sine. Okay, so now we will see the Fourier cosine and sine series. So we expand the function f of x by reflecting it in the y-axis, so that f of minus x is equal to f of x. Okay, f of minus x is equal to f of x. Then the extended function is called as a even function. That is, so already we deal with this uh, function, that is nothing but f of x is equal to f of minus x. Then the function is said to be the even function. But here we are writing in terms of the half range expansions. So that's why. But this then the extended function is even, for which bn value is equal to 0. That is, if it is an even function, we simply put bn value is equal to 0, and we'll have only a0 and an expansions, or a0 and an series. That is nothing but a0 and an values we have to be find out. That is Fourier constants. The expansion containing only the cosine terms is known as the half range Fourier cosine series. Okay. And next is, if we extend the function f of x by reflecting it in the origin, okay, by reflecting it in the origin. Here, by reflecting it in the y-axis, here it is reflecting it in the origin, so that the function is given as f of minus x is equal to minus of f of x. Then the extended function is an odd, and for which a naught will be is equal to 0 and an will be is equal to 0, not bn here. It is an will be is equal to 0. Then the expansion containing only sine terms. This is known as the half range Fourier sine series. Okay. In the half range Fourier cosine series, bn value will be is equal to 0, and it contains the expansion contains the only cosine terms. That is, it contains a naught and an related. Okay. And next, if it is an odd function, it contains only bn terms. That is nothing but sine series terms. So a naught and an value will be is equal to 0. That is, Fourier constants are becoming 0. Okay. So this is the way. This is the way you have to represent the Fourier cosine and sine series term. Okay. Right. In terms of even and odd. So now we will see the Fourier cosine series and sine series, which can be represented. The function can be represented over the interval of 0 to a. Okay. Right. So for half range cosine series, it is cosine is nothing but it contains only the cosine term. That is nothing but f of x is equal to, for this bn value is equal to 0. It contains only a naught and a. Okay. Right. So the half range cosine series can be represented as f of x is equal to a naught by 2 plus summation n equal to 1 to infinity. So here n is equal to 1 to infinity. an cos n pi x by l. So this is the general half range Fourier cosine series expansion for a given function f of x. So where a naught is equal to 2 by l 0 to l integral 0 to l f of x into dx. Okay, and similarly an is equal to 2 by l integral 0 to l f of x cos n pi x by l into dx. In previous, we have a Fourier series for a naught value as general Fourier series for a naught value as 1 by l, okay, minus l to l f of x, okay, f of x, sorry, 1 by pi minus pi to pi f of x into dx. Next we'll have the an is equal to 1 by pi, similarly minus pi to pi, okay, f of x. We'll have the cos nx into dx. So it is Fourier series, but we are representing in terms of half range. For half range, how you are going to represent this cos function cos n pi x by l, and the limits are 0 to l, that is 2 by l, 0 to l. It is defined for only half interval. Okay, that is nothing because it is an even function. Because it is an even function, that's why it is represented only in the cosine terms. Okay, so that's why we will represent as 2 by l here. Okay, right. And similarly for half range sine series, or it can be an odd function. So it can contains only bn, that is nothing but a naught and an values are is equal to 0. Okay, right. So now Bn is equal to f of x equal to, the series can be represented in terms of the sign. So summation n equal to 1 to infinity Bn into sine n pi x by L, where Bn is equal to 2 by L integral 0 to L f of x sine n pi x by L into dx. Okay, this is the way you have to find out the half range Fourier cosine series and the sine series expansions. Okay. Right. So now we'll see the so it is for in the interval of 0 to L. It is for the interval of 0 to L. In place of L, if you substitute pi, in place of L, if you substitute the pi, then how this Fourier cosine series can be expanded. That is nothing but if f of x to be expanded as a Fourier cosine series in the interval of 0 to pi, it is actually 0 to L. So in place of L, we have to substitute as a pi. So where put L is equal to pi, then the formula, that is nothing but 1, 2, 3, whatever we have discussed previously, that is. So if you see here, that is one equation, that is half range Fourier cosine series expansion. In that, we are going to find out a naught and an. Okay, that is 1, 2, 3, 1, 2, 3, and also in the next case 4 and 5. All these equations by putting the L value is equal to 5, and this can be converted as f of x equal to a naught by 2 plus summation n equal to 1 to infinity an. Here it is cos n pi x by L actually. So, but here L is equal to what? Pi. So, if you substitute pi here in place of L, then pi will get cancelled. Finally, you get it as a cos n into x. So, this is an cos n into x. Okay. And similarly, for to calculate the a naught and an, so in place of L, we have to substitute as a pi. Okay. We have the a naught is equal to 2 by L, 0 to integral 0 to L f of x into dx. Put L is equal to pi. Then you will get 2 by pi integration 0 to pi f of x into dx. Next, an is equal to 2 by pi integration 0 to pi f of x into cos nx into dx. This is the Fourier half range of Fourier cosine series. Okay, expansion for a length of L is equal to pi. Okay. And next is similarly for the Fourier sine series. Okay. So which can be represented in the interval of 0 to pi by putting L is equal to pi. Next to the formula 4 and 5, that is the half range Fourier sine series expansion. F of x is equal to summation n equal to 1 to infinity Bn sine nx. Similarly, here also sine n pi x by L. So if you substitute L is equal to pi, then pi will get cancelled. Finally, you get sine nx. So this is the Fourier half range Fourier sine series expansion, where Bn is equal to 2 by pi 0 integration 0 to pi f of x sine nx into dx. So where a naught and an is equal to 0 for Fourier half range sine series expansion. Okay. Right. Now we'll see a problem on this. How we are going to evaluate the half range cosine series and the sine series for a given problem. Okay, right. So in the question only as given as a find the half range cosine series for the function f of x equal to x square, as given the function in the interval of 0 to pi. Actually, the interval is 0 to L, but we have to put in place of L, we are substituting as a pi here. Okay, right. Hence, you have to find this sum of the series. So by using this function, so we have to find out the half range cosine series. Okay, we have to find out the half range cosine series. From the half range cosine series, from that you can find this sum of series. Okay, right. So now we know that half range cosine series for a function f of x is given as, so f of x equal to x square, which can be represented in the interval 0 to L, which is given as f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos n pi x by L. But here he has given L is equal to what? Pi. So if you substitute L is equal to pi, now this equation is the Fourier half range cosine series can be represented as in this way. This is your required series f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx. Okay, right. So now we have to calculate the a naught and an. So now we have to calculate a naught and a. Okay, right. So if you see carefully here, so we have the A naught formula. A naught is equal to A naught is equal to 2 by L. Actually, it is represented as 2 by L integral 0 to L f of x into dx. But here L is equal to pi. That's why in place of L, we have to put it as pi. 2 by pi integration 0 to pi f of x into dx. What is f of x he has given? F of x equal to x square. Okay, f of x equal to x square. So 2 by pi integral 0 to pi x square. In place of f of x, we have to substitute as x square into dx. So now we have to find out integration x power n. We have to use the formula for this integration x power n. What is that? X power n plus 1 by n plus 1. In place of n, we'll have the value as 2. That is x power 2 plus 1 by 2 plus 1. That is x power 3 by 3. Okay. So this is for only integral x power n formula, but we'll have the limits, lower limit and the upper limit. Apply this lower limit and upper limit in this function. That is nothing but in this equation. This is integrated with respect to x. That's why you have to put upper limit in place of x and the lower limit in place of x to get the final value. So this 3 is a constant which can be kept outside. So 2 by 3 pi into, in place of x, we have to substitute as a upper limit pi. So we'll get it as a pi cube minus. So now we have to substitute the lower limit in place of x. 0 cube. 0 cube is nothing but 0 only. So finally, a naught is equal to, if you simplify this, 2 by 3 pi into pi cube. 2 by 3 pi into pi cube. Pi in the denominator and pi in the numerator. Okay, there are 3 pi terms here. So one pi term will get cancelled, you get as a pi square. So finally 2 pi square by 3. So you got 2 pi square by 3. Okay, this is your a naught value. This is the way you have to solve the a naught value. Okay, and next we have to find out the an value. This is very important. Right. So an is equal to 2 by L. Actually, we have to define the L is equal to an is equal to, actual formula will be 2 by L 0 to L f of x cos n pi x by L into dx. This is, but here L is equal to pi. Okay, if you substitute L is equal to pi, this can be converted as 2 by pi 0 to pi f of x cos nx into dx. Okay, so what is f of x value? X square. In place of f of x, you have to put x square. Now this is the integration contains the two functions. That's why you have to apply the integration uv rule. You have to apply integration uv rule. So before going to find out, before going to apply this uv rule, first we have to identify which is a u function and which is a v function. So this for this we need to use this islet. What is this islet? Islet is nothing but I is nothing but inverse trigonometric functions. If any, if in a given if in a given term, if it contains the inverse trigonometric function, then it will become a u function. So there are no inverse trigonometric functions in a given function. Logarithmic function, there is no logarithmic function. Algebraic function, yes, we have a algebraic function here. What is the algebraic function? X square. So x square plus 3 x power n, whatever it may be. Okay, that all comes under the algebraic function. Now this will become the u function, and remaining the second function can be treated as a v function. Now u will be taken as a x square and v will be considered as a cos nx. Okay, so u will be x square, v will be cos nx. Okay, so now we have to differentiate this u. So in integration uv formula, what is the uv formula? Integration uv, integration uv is equal to integration uv dx is equal to u into v1 minus u dash into v2 plus u double dash into v3, so on. Okay, this series can be expanded until the u term will be is equal to 0. Okay, so first u value by applying a islet, then you can find out, you can identify that which is a u function and which is a v function. U is equal to x square. So you have to differentiate the u term with respect to x. and v term should be integrated. U term should be differentiated and v term should be integrated. So u will be differentiated. U dash differentiation of x square 2x. And next we have to derivate for the next higher order. Okay, differentiate with respect to again with respect to x. Okay, so u double dash is equal to 2 is a constant. Okay, differentiation of x is nothing but 1. 2 into 1 is nothing but 2. Okay, next to u triple dash. Okay, we have to differentiate again with respect to x. This is the first differentiation, second differentiation, and third differentiation. So differentiation of 2 will becomes 0. Okay, differentiation of 2 will become constant. It is a constant, that's why it will become 0. So we have to make you have to expand this series up to u triple dash. That is nothing but at u triple dash. So a third derivative, the u value will become 0. Okay, so up to here only you can take the values. So u double dash is equal to 0. Up to here only you can expand the series. Okay, next if you go for the v term, it should be integrated. That is nothing but v1. v1 is nothing but integration. Integration of cos, it can be represented as a sin nx. Integration of cos nx can be represented as sin x, where x coefficient can be n here, it can be taken as a denominator. Okay, right. So sin nx by n. Next is v2. So v2 is equal to integration of sin. It can be minus cos, and integration of sin nx is nothing but minus cos nx by. Already you will have the n term, one n term in the denominator. Again, you will get the one more x coefficient value, that is n in the denominator. That is nothing but n square. Okay, next is v3. v3 is equal to minus term will be kept as same. Integration of cos is nothing but again sin nx by, again the x coefficient is n. Already we will have in the denominator n square. N square into n, again you will get it as a n2. So for every integration, this n value can be multiplied. That is n. First we will have the n square, n cube, n power 4, so on. Okay, right. So now we have to apply this u value. U into v1. U into v1. Next is u dash into v2. So next is u dash into v2. Next is u double dash into v3. That is u double dash into v3. Next, if you take the next series, that is nothing but u triple dash into v4. If you calculate the v4 also, then u triple dash value will be 0. So if u triple dash value 0, 0 into something v4 value, whatever the value you will get for v4 integration value, so that will become 0. So that's why we have to expand this series. We have to expand this series up to u double dash into v3. So this is your series expand. Up to here only you can expand the series. So u into v1. So this is your u, this is your v1. Okay, u into v1. U value will be x square. v1 will be sin nx by n here. Okay, next is minus u dash into v2. What is u dash? 2x. What is v2? Minus cos nx by n square. So u dash into v2 minus cos nx by n square. Next plus. Next is u double dash into v3. U double dash is 2. v3 is minus sin nx by n cube. So u double dash into minus sin nx by n3. What is the limits? Limits are 0 to pi. So just we have done the integral uv dx only. We have expanded this series. Now we have to apply these limits. Upper limit is pi and lower limit is 0. So you have to apply this upper and lower limit in this series. Okay. So before going to apply the upper line lower limit, just we have to expand the. Now we have to expand this. Now you have to simplify this series. Okay. So here in this function, so this is your u and this is your v1. In this, if you have any constant terms and plus minus terms are there, whatever it may be, it should be taken outside for the simplification. So here you will have the x square. Only x related terms should be kept inside and remaining terms will be kept outside. So in this, n is a constant. Okay, in the denominator, and in the numerator you will have the x square into sin nx. So x square into sin nx will be kept in one braces, and the constant term 1 by n. So it is denominator now. So that's why 1 by n. It can be taken outside. So this can be simplified in this way. Next is u dash into v2. Okay, in this, if you see here, minus is outside. Here also you will have the minus term. Minus into minus, you will get it as a plus here. So 2 is a constant and n square is a constant, which can be taken outside for simplification, because these are not x terms. only x term should be kept inside in order to apply this upper and lower limit. So 2 by n square. So 2 by n square can be kept outside. This minus into minus will becomes plus. Okay. 2 by n square into x cos nx. Okay. X and x into cos nx. Next is again plus into minus. Okay. Plus into minus. Plus into minus is minus. So 2 by n cube is a constant. So kept to 2 by n cube, 2 by n cube as outside. Okay. Into we'll have only the sin x term. So write only the sin x term. So apply this upper and lower limit to this entire function. But when you will apply this pi upper limit in the sine function, okay, or lower limit in the sine function, either it can be sin nx or sin 2nx or whatever it may be. Okay. Right. That is sine. If you are apply this upper limit and lower limit in sine function, this will be 0. Sin n into 2 pi. Okay, in place of x, if you substitute, that is sine 2n pi. Simply it is represented as sine 2n pi or sine n into 0. If you substitute pi, okay, or if you substitute 2 pi, or if you substitute 0, wherever you will have the sine function, okay, then this value will be becomes 0. Okay, this value will become 0. So what you will do? Simply wherever you will have the sine term, sin nx, okay, so simply you have to put it as a 0. So if this value is 0, then this value is multiplied with any function, then this will also becomes 0. Now this whole term will become 0. So here also we'll have the sin nx function. If you substitute the upper limit and lower limit, this entire function will be 0. This 0 is multiplied by 2 by n cube. Again, this whole term will becomes 0 only. Okay, right. So this term will gets vanish. This term will also will gets vanish. Only the leftover term will be the cos function. Okay, only the middle term will be available in order to simplify. Okay, right. So this term will be 0 and this term will be also 0. Okay, see here, this one is 0 and this one is 0. Only will get the middle term. Okay, right. So apply this upper limit in all this, then this will be 0 and this will be 0. And if you apply here 2 by n square into, if you apply the upper limit, pi into cos n pi, pi into cos n pi, minus apply the lower limit, minus lower limit is 0 into cos n into 0. So here we'll have the x term. So in place of x, if you substitute the lower limit 0, 0 into something, again you will get it as a 0. Okay, right. So you will have the only this one. So 2 by pi will be kept as same into 2 by n square. So pi here. So cos n pi value. What is cos n pi value? Cos n pi value, already we have dealt these formulas in the Fourier series. Okay, in the introduction class, cos n pi value is minus 1 whole power n. So we have the cos 2n pi value or cos n into 0 value. Cos n into 0 value or cos 2n pi value, its value will be is equal to 1. So remember these formulas whenever you are finding the a naught and an. Okay, this is very, very important. Okay, so cos n pi value will be minus 1 whole power and this will be 0 only. So we have only leftover term will be this. So 2 by n square pi into cos n pi value minus 1 whole power n. So if you simplify this, 2 into 2, 4. Okay, this pi and this pi will get cancelled. Finally, we will get minus 1 whole power n by n square. That is 4 into minus 1 whole power n by n square. Okay, this is the way you have to simplify the an value. Okay, so the very important is nothing but so UV rule. So if you carefully do the UV rule and if you carefully do the simplification part, and you can easily apply this upper limit and the lower limit in the given functions or in the given equation in order to get the an value. Okay, right. So finally, you have to substitute this a naught and an in the half range Fourier series expansion. Okay, what is the half range Fourier series expansion? That is f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx. Okay, an cos nx. What is a naught value? A naught value is nothing but 2 pi square by 3. 2 pi square by 3 by 2. So this is your a naught by 2. So this 2 will get cancelled. You will get it as a pi square by 3. So which is represented here. Okay. Next is plus summation n equal to 1 to infinity. What is an value? An value is 4 into minus 1 whole power n by n square. We got. Just now we have done this an. Okay. Into cos nx. Okay. Right. So here 4 is a constant which is kept outside. Okay, remaining terms will be kept inside of this summation, because here this n is varies from n equal to 1 to infinity. Then you have to expand this series by putting n is equal to 1, 2, 3, so on in this equation or in this function. Okay, so that's why 4 should be kept outside. Either it can be plus 4 and minus 4. So here it is plus 4, then you can take plus 4 outside. If it is minus 4, you can take minus 4 outside. So what is f of x actually? F of x is your x square. So x square is equal to pi square by 3 plus 4 into summation n equal to 1 to infinity minus 1 whole power n by n square into cos nx. So put n is equal to 1 in this series. What will get? Minus 1 whole power 1 by n square 1 square cos x. Cos 1 into x. That is nothing but cos x. Cos x by 1 square. That is minus 1 whole power 1 value is nothing but. So if you put n is equal to 1, you will get minus 1 whole power 1. Then you will get it as a minus 1 or minus. So minus cos x by 1 square. Then if you put n is equal to 2, then you will get plus 1. So cos 2x by 2 square. Next, for every odd values, n is equal to 1, 3, 5. So this minus 1 whole power n value will be minus. For every alternative odd values, that is alternative values or odd values, you will get minus term to the cos function. Okay, for even values, you will get the plus term. So minus cos x by 1 square plus cos 2x by 2 square minus cos 3x by 3 square, so on. Okay, so now what he has, so this is your final Fourier series, half range Fourier series, Fourier cosine series expansion. But what he has given in the question, so we have to find the sum of the series. We have to find this sum of the series. How you will get the sum of the series? But here in this series, we'll have this, we'll have the cos x, cos 2x, and also we'll have the x term. So we have to eliminate this x term. So if you want to eliminate this x term, what we have to do? Either you have to put x equal to 0 or x equal to pi or x equal to pi by 2. Randomly you have to put these values in order to get that series. So whenever you will have the cos series, then you have to put maximum, majority of the case you have to put it as a x equal to 0, or sometimes there may be x equal to pi also. Okay, so if you put x equal to 0 in the above series, what you will get? So if you put x equal to 0 in this series, okay, cos 0 value is 1, okay, minus 1 by 1 square, plus cos 2 into 0 value is also 1 by 2 square. Next, minus cos 3 into 0 value is also 1. So minus 1 by 3 square plus 1 by 4 square, so on. So here x value is 0. Let the LHS said x square. So 0 square, you will get it as a 0. 0 is equal to pi square by 3 plus 4 into. So this entire series by putting x equal to 0. Okay. So if you take this pi square by 3 at LHS side, what you will get? Minus pi square by 3. Minus pi square by 3 is equal to 4 into this entire series. 4 into this entire series. But this series will contains, the first term will be minus, second term will be plus, third term will be minus, fourth term will be plus. But in the given problem, the series contain the first term will be the plus, second term will be the minus. Okay, so you'll get plus, minus, plus, minus. But here you will get in the reverse order. So what we have to do? So you have to take the minus term as common in this series. If you take the minus term as common in this series, what you will get? So you'll get minus 4 into 1 by 1 square. The first term can be changed as, instead of minus 1 by 1 square, it can be converted as 1 by 1 square. When you will take minus term as common. Next term is minus 1 by 2 square. Next is minus 1 by 3 square, so on. Okay, so finally you will get the series as like that. So at the right side, what you will get? So minus 4 pi square by 3 is equal to LHS side, you will have this term. Minus 4 into at RHS side, you will have minus 4 into that entire series. So this minus minus will get cancelled, and this 4 is multiplied with this series. Now this will be taken to the LHS side, which will be shifted into the denominator. Then pi square by 4 into 3. What is pi square by 4 into 3? That is pi square by 12. So this is the simplification we need to solve. Okay, this is the series we have to be find out. Okay, from the given problem. So next we will go for the one more problem on this. Okay, so he asked to find out the Fourier half range cosine and sine series for this given function. So you have to find out both the series, that is cosine series and the sine series. Okay, so now first we have to find out the Fourier half range cosine series. So for Fourier half range cosine series, the function can be given as same f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx into nx. So we have to find out a naught and a n. What is a naught? A naught is equal to 2 by pi integral 0 to pi f of x into dx. A n is equal to 2 by pi integral 0 to pi f of x into cos nx into dx. First we have to find out the a naught value. A naught is equal to 2 by pi integral 0 to pi f of x into dx. What is f of x? Pi minus x. Okay, now what we have to do? So we have to divide this integration. That is integration pi into dx minus integration x into dx, and we'll have the limits for this. So don't forget this limit. Just I have mentioned that how we are going to divide this integration to this pi and x. Okay, just for simplification. Either if you know the very well, if you are familiar in the integration, you can do directly. Then you can do directly the integration to this pi minus x. Otherwise, you can divide this and you can simplify. It's better. Okay. So this pi is a constant which can be kept outside. So then what you will get here? 1 into dx. Pi will be kept outside. What is integration 1 into dx? X. Okay, so limits are 0 to pi. Next is minus. So what is integration x square by 2? What are the limits? 0 to pi. Okay. Apply the upper limit and lower limit in this x, and apply the upper limit and lower limit in this x square. Then what you will get is nothing but, so pi into upper limit is pi. Substitute in x, pi minus 0. Okay. Upper and lower limit, if you substitute, you get pi minus 0 for the first term, minus. Okay, next term is x square by 2. That is 1 by 2. Okay, sorry. So substitute this upper limit here. So in this x, pi square by 2 minus, if you substitute the lower limit, 0 square by 2, that is nothing but 0. Okay. If you simplify this, what you will get? Pi square. So 2 by pi into, we'll have the 2 by pi into pi square. Okay, here pi into 0 is nothing but 0. So no need to write, minus pi square by 2. So minus pi square by 2. So pi square minus pi square by 2 is nothing but you will get pi square only. Okay, pi square minus pi square by 2 is nothing but pi square. If you simplify by taking the LCM, then you will get pi square by 2. So these two will get cancelled, and pi will get cancelled. Finally, you will get a naught value as a pi here. Okay, so this is the way you have to simplify the a naught. Okay, next we have to find out the an value. So again, in place of f of x, he has given pi minus x. Okay, so now again, this can be divided as individually. Okay, so that is pi into cos nx as one term, and next is x into cos nx as other term. Okay, right. So in this, you will have the pi is a constant here. It is not a function actually. It is a constant term. So this pi will be taken outside. Okay, this pi will be taken outside, and then you have to directly integrate with respect to cos nx only. Okay, so if you take this pi outside, then what you will get? To pi will get cancelled. You will have only the 2 term here. 2 into integration cos nx. What is integration cos nx? Sin nx by n. X coefficient is n, so you will get in the denominator sin nx by n. So where integration limits will be 0 to pi. Okay. Next is here we'll have the two functions, x function and cos nx function. Okay, so here x will be the u, okay, and cos nx will be the v. By using the eyelet, so you can find out which is the u function and which is the v function. So here we'll have the algebraic function as first, that's why it is a u function, and cos nx will be the v function. So applying the uv rule, integration uv rule. So u into v1 minus u dash into v2 plus u double dash into v3. So here by using this, u value will be the x, v value will be the cos nx. Okay, so u dash, differentiation of x is nothing but 1. So u double dash, differentiation of constant is nothing but your 0. Okay, next is v1 cos nx, integration of cos nx is nothing but sin nx by n. Next is v2, that is equal to integration of sine minus cos nx by n square. Okay, so now u into v1, u dash into v2. So u double dash into v3, that is nothing but 0 only. Why? Because u double dash value is 0. So you have to find out only up to u into v1 minus u dash into v2. What is u here? X. What is v1 here? Sin nx by n. So if you simplify that, 2 by pi will be same. Okay, so if you simplify by using the u into v1 rule, x into sin nx by n, that is x into sin nx by n. That is your first term. Next is minus. So minus into, okay, u dash into v2. What is u dash here? So minus u dash is 1 into v2. What is v2 here? Minus cos nx by n square. Okay, cos nx by n square. This minus into minus, you will get it as a plus, which is represented as 1 into cos nx by n square. 1 into cos nx by n square, which is directly written here. So now apply this upper limit and lower limit. Okay, so here in this case you will have the sine term. Here also you will have the sine term. If you apply this upper limit in sine and lower limit in sine functions, this will becomes 0. Okay, so the first term is 0 in this case, and in this also the first term will be 0. So this whole term will be 0 and this whole term will be 0. Only the leftover term will be this. So for this you have to multiply by 2 pi. 2 pi into this term. Okay, 2 pi into this term. So that is 2 by pi. Okay, the constant here it is n square. So this term will be 0. This term will be 0. Okay, and this term will be 2 by pi. Okay, into n square is a constant which can be kept outside. 2 by n square into pi. So if you substitute the upper limit, cos n pi. What is cos n pi value? Minus 1 whole power n. Minus. Okay, if you substitute the lower limit, what you will get? Cos n into 0. Cos n into 0 value is 1. Okay, so finally you will get only this value. So finally you will get 2 by n square into pi into 1 minus. Okay, so here you will have the minus term. If you multiply this minus term internally, so this will be interchanged. These two terms will get interchanged. Then finally 1 minus minus 1 whole power n. This is your an value. Okay, right. So what is an here? An is equal to 2 by n square into pi 1 minus minus 1 whole power n. Okay, now we have to test for the n values. When n is equal to what? Okay, when you substitute n is equal to odd values in this, what you will get is nothing but, so you will get 1 minus of minus 1, that is 1 plus 1. You will get the final an value as 4 by n square into pi. So when n is equal to what? That is n is equal to 1, 3, 5, 7 for all odd values. So this internal term will be always 2, 1 plus 1 only. So finally you will get an value for odd values 4 by n square into pi. For even values, so this will be a positive value 1 minus 1, you will get it as a 0. 0 into something, you will get it as a 0. For n is equal to 2, 4, 6, 8, this value will be is equal to 0. An value is equal to 0. So here an value is defined for only odd values, not for even values. Why? Because for even an value is equal to 0. So now substitute a0 and an in this series. So where a0 value is equal to pi, so you will write it as a pi by 2. What is f of x? Pi minus x is equal to a0 value, you got it as a pi. So pi by 2 plus summation n equal to 1 to infinity. What is an value? An is nothing but 4 by n square into pi for odd value. That's why n is equal to 1, 3, 5, 7 up to infinity. What is an value? Is nothing but 4 by n square into pi cos nx. Okay, so this is the way you have to evaluate the problem when you will get this type of an values. Okay, this type of an values. Okay, right. And similarly you can find out for the bn the same way. You can find out for the bn. F of x equals summation n equal to 1 to infinity bn cos nx, where bn is equal to 2 by pi integration 0 to pi f of x sin nx into dx. Okay, right. So again the same way what we have did in the previous case, that is for an value. So f of x in place of f of x is pi minus x into sin nx. Divide this one. Okay, pi into sin nx into dx minus 2 by pi into integration 0 to pi x into sin x. Again you have to apply the uv rule here. This pi is a constant which can be kept outside, and this pi will get cancelled. You will get have only the 2 here. 2 into integration sign minus cos nx by n. Limits are 0 to pi. So if you see here, after applying the UV rule, then you will get it as the first term as minus x cos nx by n, because we did this UV rule for different problems previously. Okay, so just you have to practice this one. So if you don't get, you can ask me. So minus 2 by pi. Okay, if you apply this UV rule, then the first term will be u into v1 minus x cos nx by n plus u dash into v2 value, that is 1 into sin nx by n square. Okay, so limits are 0 to pi. So wherever you will have the sign term, simply you have to put it as a 0 when you will apply the upper limit and lower limit. So what is the leftover term you will have? So you'll have only this term and this term to simplify. So for this term, so this minus will be taken outside, this n will be taken outside for simplification. Minus 2 by n into, if you supply this upper limit cos n pi, what is cos n pi value? Minus 1 whole power n. Minus, if you substitute the lower limit, cos n into 0 value is 1. That is first term is simplified. Next, if you go for the next term, so this minus into minus will be plus. So that's why plus 2 by pi into n. Okay, integration x into cos nx. Okay, if you substitute the upper limit, pi into cos n pi, pi into cos n pi value is minus 1 whole power n. Okay, if you take the lower limit, minus, so minus 0 into, here you will have the x term, 0 into cos n into 0, something, so any value is multiplied by 0, then you will get it as a 0, and the third term will be 0, then it will be 0 only. Okay, so finally you will get it as a, if you simplify this entire bn value, then you will get a bn is equal to 2 by n. Okay, if you simplify this entire term. Okay, right. So substitute that bn value after simplification, then substitute in the Fourier half range sine series. So wherever you have the bn, substitute that 2 by n and expand this series. N is equal to 1, 2, 3, 4. So for n is equal to 1, you will get as a, if you take 2 is a constant which can be kept outside, 2 into sine 1x by 1, sine x by 1. Next n is equal to sine 2x by 2. Next n is equal to 3, sine 3x by 3, so on. Okay, so this is the way you have to simplify the half range Fourier cosine series and sine series expansions as problems. Okay, so finally in this class we have studied about how you are going to apply the half range Fourier series, half range Fourier cosine and sine series for a given interval 0 to L, where L is equal to pi. Okay, for a given interval L is equal to pi. So we have find out this half range cosine series and the sine series problems. Okay, right. So now this is the frequently asked questions. Okay, so find the Fourier cosine and sine series for f of x equal to x in interval of 0 to pi. The next problem is f of x equal to e power x. So whatever the problem I have given, these are very important and asked previously. So now we have to find out this. The assignment question is nothing but, so now we have to find out the for sin x function, Fourier half range cosine series for the function sin x in interval of 0 to pi. And also you have to find out for the cos x function for a half range sine series, half range or a half sine series or a half range sine series problem. Okay, so right, if you won't get, I can explain. Okay, thank you. The textbooks for this is nothing but, these are the textbooks we have to follow in order to get the knowledge on the Fourier series. Okay.